This DVD is about macadamia irrigation. Macadamias require water because it's a resource in the photosynthesis process. It cools down the photosynthesis machinery, transports the nutrients into the tree, and most importantly, it keeps the stomata open for CO2 to enter into the crop, into the plant. Because it's an oilseed crop, it needs carbon for photosynthesis. When we consider irrigation, we need to focus on the soil, the climate, and the plants itself. Well, vapor pressure deficit has a major effect on the irrigation of macadamias. It is basically, it's a calculation that you can make. You use the humidity, the temperature, and wind. Most areas in South Africa has higher evapotranspiration than annual rainfall. That's the need to irrigate. The amount of rainfall and the distribution thereof through the season determines how we think strategically about our irrigation. If we have a lot of rain, high rainfall area, and it's well distributed, we may supplement rainfall with irrigation and just add a number of strategic irrigations, maybe during flowering or fruit set. In areas of low rainfall, we would constantly irrigate and just leave space in our reservoir for rain to refill it. When we consider irrigation of macadamia orchards, the soil is one of the most important things that we need to consider. Characteristics of the soil that's of particular importance is the soil texture, soil type, soil depth, infiltration rate, restrictive layers in the soil, and mulch. Soil texture is very important for irrigation purposes because it determines the amount of water that the soil profile can hold, that in combination with the organic matter content of the soil. In a typical sandy soil like this, it holds much less water than a clay soil. Soil depth affects irrigation because it determines the volume of the soil reservoir, and the effective root zone is basically up to where we find roots in the soil profile. In this specific profile, there's active roots quite deep, and normally in macadamias we have a very concentrated, very shallow root zone. We need to keep in mind how deep the soil is, how deep the effective root zone is, because that determines our frequency of irrigation. A restrictive layer in the soil is a layer that restricts the root growth to a deeper level into the soil. It can be due to a whole range of factors. Compaction layer due to tractor movement. It can be subsoil layer that's very hard or rocky. It can be a soil chemical characteristic that quickly changes, or just a variation in soil texture, a shallow water table, anything that restricts root growth. Infiltration rate determines how quickly water goes into the soil, and it can influence how wide the water spread, but it can also, if there's problems with infiltration, it can mean that the water cannot enter into the soil. Mulch can prevent excess evaporation, and it basically keeps the roots moist and alive, and as it breaks down, it increases the soil, the organic matter content of the soil, and therefore increases the water holding capacity of the soil. There are a few soil water concepts that we need to understand before we can go forward. I'm going to liken the soil to a sponge. When we irrigate, we saturate the soil. When the soil is saturated, there is no air left in the soil. When I allow free water to drain out of the soil is not saturated anymore, and we reach a point that is defined as field capacity. That's the amount of water that the soil can hold without any further drainage occurring. Field capacity is the ideal condition basically for plants in the soil, because there are enough moisture and enough air spaces in the soil. A portion of the water that is left in the soil is easily available to the plant. Depending on your irrigation strategy, you will have your refill point either in the middle or the upper sections of the easily available water. So the plant needs to use very little energy to get the water out. There is still a lot of water left in the soil. When I press out all the water, this would be considered permanent wilting point. There is no more water available to the plants, even though there is still water in the soil. Macadamias have some unique characteristics that help them survive water deficit situations. For example, they have sclerophilic leaves that help them to withstand very low water potentials. Under certain conditions, they also develop proteoid root clusters that help them to scour for water. Different macadamia varieties use different amounts of water. As the industry, we are beginning to understand this, but we're still a long way from norms for each of the different varieties. As can be expected, young macadamia trees use less water than mature trees, but relatively speaking, during winter we scale down less than in a mature orchard. It's important to keep in mind that when you blank a young tree into a mature or semi-mature orchard, that you make adaptations to the irrigation system. We need to tailor our water and irrigation according to the phenological stages of the plant. Water requirements and irrigation requirements differ during the growth cycle, during the phenological stages of the macadamia. Basically, during the post-harvest stage, water requirement is low relatively, also because it is winter. Water use, water requirements increase when the flowers come out. It's at a peak normally during September, October, during flowering and fruit set, when the climate's also the driest. Another very critical stage is during oil fill in the latter part of the summer. The atmosphere drives water loss through evapotranspiration. The soil determines how much water is available to the plant. The irrigation system determines how long an irrigation is to refill this reservoir. Cultivar water requirements differ. Critical phases for irrigation is during flowering and fruit set, during the nut drop period, and during oil fill and maturation.